Well, class, welcome to my, you might call it my man cave. We'll show you around. There's the mice that are spending the summer with me. Got my antlers up there, my old hats. So you might call this a man cave, but probably better to say an old man cave. Anyway, we're going to do some preparation for our next nature walk. So let's see what we got. Let's turn this thing around. So what we got some pliers, we got a ruler, we got a little piece of wire here. Remember these circular wire 1 meter square hoops that we have? We're going to be using those. And we got 4 stakes we're going to be using. And we have some twine we're going to be using, and our butterfly net, our insect nets over there. We're going to be using that. So let's just pause for a second and let's see what we're doing. So class, this study is going to be, this field trip, nature walk, is going to be a study of biomass and the pyramid of life in the biomass. So we have to get a few things prepared. So let's see how we're going to do that. So we have our small little wire square, 10 centimeters square. The next step is go out in the field. So there's a alfalfa field close here, and we're going to go there, and we're going to have to be marking out our study area and a few other things. It's going to be very interesting, so stay with us. Okay, class, we're out here in our study area, this beautiful alfalfa field. So we're going to get set up here. It's going to take just a second to do that. Okay, we have things set up. We took our trusty tape measure here, and we set up a study area here with some stakes. Now these stakes are 10 meters apart. So we have a 10 meter square area here. And we have this whole field. It's a half mile by, it's 0.5 miles by 0.4 miles. So we're going to use some of the technique that we used in our population study to do a sample and try to determine the biomass of this alfalfa field. First thing we're going to do is insect sweeps. Now the insect sweeps, of course, we're going to be using the insect net. So let's show you how we do that. That was also shown earlier, but this will be a little bit different. Okay, we got to go get inside of our study area. So what we did, we swept the whole area as thoroughly as we could, and we have our insects down on this end of the insect net. So what we're going to do, we're going to take a baggie, and we're going to take our net and turn it inside out and drop our insects into this little baggie right here. Now there are going to be some plant material with them, and of course we're not going to get all of the insects, but we're going to get a lot of them, and we're going to figure out the biomass of the insects in this study area here and be able to convert that to the whole field. Okay, so here's our insects. You can see in there we have ladybugs, which are good. We have some other organisms, a lot of little, they call them insidious beetles or iridescent beetle. They're not too good for the alfalfa field. So we're going to do that. Next thing we're going to do is to take a plant sample. Okay, and we'll show you how we do that. Remember this little thing that we made? Now we've got to put it to use. What we're going to do is we're going to take 10 samples of plant in this area right here. So we're going to turn this around and show you how we're going to do this. We're just going to take this, we're just going to put it on the ground, drop it right down there. Okay, drop it right there. And what we're going to do within this little wire area, we're going to take all of the plants that we can get. That's all the biotic material and nothing outside of it. But we see we have a little bit inside of it right here we're going to get. Now we're going to do this in 10 places. So we're going to have a bunch of plants like this. Okay, this is alfalfa. So let's go to the next spot. Okay, here's our next area. You can see our little wire right down here. So we're just going to take all the plants right there, all the living material out of that 10 centimeter square area. Anything outside we're not going to take. Now we could dig up the roots. We could dig up the roots and include the roots in this biomass study, but we're not going to do that today. We're just going to do what's above ground, which is going to be accurate enough for what we want to do. Now you can see this area right here is doesn't have many plants in it as the rest of it. So we're only going to take the living material, the plant material that's within this area. So in this little area we don't get very much. And if you remember from when we did the population study, we're doing a sample. And so the sample is random. So we have to take a random sample of 10 of these in our area, which we've done. And we're going to use that and multiply it and figure out the biomass for the whole area. And you might say, why do we have the insects? Because the insects are biomass also. And so next step is when we measure biomass, we're going to weigh it. And when we weigh it, it needs to be dry. So we're going to take these back, we're going to lay them out so they can dry out. Then we will weigh them. That's the next step. Okay, class, we have our plant sample in our baggie right here, our trash bag. We've got our insects here. We've got all of our stakes collected. We've got our tripod collected. We're going to head back to the lab so we can get the next step done. Okay, we're back in the lab. We're going to take our little paper bag and put it right there on the scale. Remember how to do this. We're going to push there. That zeroes it out. Now we can go put our sample in here. Okay, here's our sample. It's been drying out here in the sun, just like an oven. So we're going to put it in our little bag and we're going to go weigh it. Okay, we got our sample right here. Stuffed it all in there. And we're going to go down and look, and it weighs 40.94 grams. Okay, sample done. Now we got to do a little bit of multiplying. Plus we have to weigh our insects, and we'll get to that next. Now we've taken our insect collection and we've separated the plant material from the insects. Now we need to separate the herbivores from the carnivorous insects. Kind of tedious work, but this is what scientists do. Sometimes the work they do is tedious. So we're just about got this done. This is a ladybug, of course. Ladybugs are very beneficial. That means they're good for the crop. They actually eat the eggs of harmful insects. So we're going to separate them out over here. Now right here, of course, are our ladybugs. 4 of them, but this one here is a wasp, and it's one of those wasps that we find in the fields around here that are very beneficial. They attack and kill these other insects. Now there's some here that, like this is an immature leaf hopper. And we have the striped beetle. Where's one of those? Striped beetles. There's a little grass. There's another leaf hopper. Now these all right here are harmful to the plant. And there's a striped beetle right there. Or you'd call it an iridescent beetle. And this one right here, this one here, can you see the triangle right there on its back? It looks kind of a yellowish color right there. It has like a little triangle. This one here is a lygus bug, and it's an immature. But this one here, if they multiply in an alfalfa field, can cause a lot of harm. So alfalfa farmers often check. They pay people, entomologists, to check for the harmful insects. Okay, so this one's immature. So let's hang on here and see what else we can do. There, we adjusted the light, so maybe you can see the triangle shape on the back of this lygus bug right there. It looks kind of yellowish. Okay, so what we're going to do, we have our scale, and they're very sensitive. All you have to do is take your hand and go like this, and it causes the scale to change and float. So what we're going to do, first we're going to zero the scale. So it's 0, and then we're going to put our insects on there one at a time until we have all of our herbivores, or the plant-eating insects. So we're going to take this card right here. We're going to use it. We're going to place it on there, and we're going to push the tare button. I'm going to zero the scale so that we can use that card as part of the scale, and we can put our insects on there. Just going to make it easier. And what we're doing is we're just sweeping, using the paintbrush, and we're sweeping these insects onto this little card here. It's very tedious. You kind of have to hold your breath while you're doing it, or don't breathe deeply, because if you do, you'll blow them all over the place. Anyway, we're almost got the herbivores done here. Okay, so this is all, as many as we could possibly get of the insects that feed on the plant directly. Now there's some in here, these little tiny ones like this. These are the aphids, and there were thousands of those, and they're so small we can't even get them all up. But I think we've got either all of them or most of them, and we did a real good job of not including any plant material. So we're going to take our little card and very carefully set it on the scale, and it weighs 0.2 grams. I'm going to write that down. So the herbivores equals 0.2 grams. All right, now doing the carnivores probably won't be so hard. Here we have one. A lot of the carnivores, you can tell this one here has a blood or a sucking mouth parts, and what it does is its mouth part look like this. Here's its head like this, and its mouth part looks like this. And of course it's got its legs back here, and then it's got its little wings on it here. Okay, but what it does is it attacks insects, and it just stabs them and sucks the blood out of them. Okay, so that's a beneficial. These are beneficials, and these are harmfuls. 0.2 grams. Okay, we zeroed a scale again. We're going to take our little card here. We're just going to get these beneficials on a card. We're going to weigh them. Okay, so we got them on the card. You just take them, our scale, we zeroed it with the card on, so it looks like a negative number now. We dropped that on there. So the beneficials, these are the carnivores, 0.03 grams. Okay. So we did our separating of the herbivores and the carnivores on the insects. Now what we got to do, we have to do a little multiplying, figure out how many's in the field. Let's see if we can figure that out. Math. Okay, so what we did, our study area was 0.5 miles by 0.4 miles, which is, I used our unit converter, 804 meters by 644 meters. And if you times 804 times 644, you get 517,776. So we're going to round that off, just for study sakes, to 518,000 meters square. We take that, our study area was 10 meters by 10 meters. That equals 100 meters square. So how many study areas do we have in that? We'll just divide. 518,000 divided by 100. Actually, we should have another 0 in here. So we have 51,800 study areas. We're going to add our extra 0 right there. Because when we do the dividing, yeah, we can drop off 2, drop off 2. Whoa, we don't need that extra 0. There we go. So our study area is there are 5,180 study areas in our giant field. And how many insects did we collect? How much biomass and insects did we collect? The herbivores was 0.20 grams. So all we have to do is multiply 0.20 grams times 5,180 study areas, and we're going to get the amount of biomass of the herbivores. The carnivores, on the other hand, was 0.03 grams times 5,080, and we'll get the biomass. This is going to be the biomass right here. Now the plant biomass, we're going to put a P for plant. That's a little different because we took 10 centimeter, remember that, 10 centimeter samples from the field. So we're going to have to do a little converting here also. So let's pause right. Math. Oh well, let's turn this around and see what we got. Okay. Remember our little wire that we put in our study? This is our study area. We took 10 samples at random in random places, very small, 10 centimeters by 10 centimeters. So 10 centimeters by 10 centimeters comes out to, we need to figure this, we had 40.94 grams. We're just going to call it 41 grams. And we had, this is study area 1, 2, 3, 4, all the way down to number 10. It comes out to 1/10 of 1 square meter. So we have to multiply that number times 10 to find out how much is in 1 meter, which is 410 grams in 1 square meter. But how many square meters were there? There were 100. So we have to take that number and times it by 100. Okay, and what are we going to get? We're going to add 2 zeros to that. We're going to get 41000, 41,000 grams in our 10-meter study area. Okay. Math. Okay, so what we did some converting. We found out we took our 4,100 grams, or it comes out to 90 pounds, or for the whole field, we had to multiply it by 5,180 because we have 5,180 study areas in the whole field. And it comes out to 466,200 pounds, or a lot, 233 tons. As far as the first order, the first order consumers, the biomass came out, we had to multiply our 0.20 times 5,180. It came out to 1,036 grams, or 2.3 pounds. The second order consumers, 0.03 grams times 5,180 comes out to 155 grams, or 0.34 pounds. So if we look at the biomass pyramid, we see at the bottom we have our producers. The producers were, in that field that we studied, 466,200 pounds of biomass of producers. The first order consumers, that would be the herbivores, the things that eat the plants, 2.3 pounds in the whole field. The second order consumers, or the organisms that eat those, would be 0.3, or a third of a pound. Now, you might say, well, that doesn't sound realistic for a whole field, only a third of a pound of herbivores or carnivores. And actually, we could be pretty far. We could be off on some of our figures because we did not do an exact scientific study. But it does show us a very important thing that we need to remember about biomass. And let's look at our pyramid. Biomass decreases as you go up the energy pyramid. The same thing, energy decreases as you go up energy pyramid, but as you go up also, the biomass, mass. So what is biomass? Biomass is the amount of organic material, and we classify it as producers, first order consumers, second order consumers, and so on, okay? But this is the important thing you need to get. Biomass decreases as you go up the energy pyramid. So that was our nature walk. I hope you guys enjoyed it. There's a lot of other fascinating things that we could be doing, but you can see this particular experiment was kind of tedious. It was a lot of fun going out in the field and doing the collecting and making the observations, but then when you go back to the laboratory and you have to do the analysis and you have to do the math, it can be a little tedious and a little time consuming, and those kind of things are things that take time. In the lab, I'm always telling you, reminding you, take your time. Don't be in a hurry. Slow down. So when you're in the lab, you need to slow down and you make less mistakes that way. So again, biomass decreases as you go up the energy pyramid, or the biomass pyramid. I had fun on this one. I hope you enjoyed the trip, the nature walk. So you'll have a write-up to do if you want to do it. I hope you guys all enjoying the nature walks we've been going on. We have one more experiment we're going to do, which I think you will find fascinating. It is about warm-blooded and cold-blooded organisms and how do they react to different environments. And we have our little friendly classroom mice. They're going to participate, and we have some little minnows that we're going to collect. They're going to participate also. And so make sure you come back for that experiment. Take care.